Ettercap, Explico, and a man-in-the-middle attack. In this nugget, we're going to take a look at another utility that will allow us to do a man-in-the-middle attack. And this time, instead of just capturing the data with just Wireshark, for example, we're going to use an additional tool that's really cool. It's called Explico to help give us a bird's eye view of the data that we have collected. Where did he go? What did he see? What did he do? It's all contained for us and collectible by Explico as we're doing a man-in-the-middle attack. Let's begin. I'd like you to imagine that you and I have been hired and authorized to do a man-in-the-middle attack against a specific host on the network. So we say, great, we have lots of tools in our tool belt that can do it. And I'd like to share with you yet another tool called Ettercap that can help us do it. One of the fun things about Ettercap is it has a beautiful graphical user interface where we can just click, select, and go, and it does it all for us. Pretty neat. So once we actually have the man-in-the-middle attack going, what do we do then? Well, we could capture the data. Wireshark is a terrific tool. We could gather all the packets with Wireshark for later analysis. But another tool that we could also use besides Wireshark is we could use something called Explico. Now, Explico can actually take Wireshark files and analyze them for us. It also has the ability to do a direct feed into Explico. So we can capture all the traffic, and it gives us another really handy tool to kind of get a bird's eye view of what's really happening on that session that we're eavesdropping on. So let's set the stage for the eavesdropping attack. If we have a computer here, we'll call that PC1. It's at 192.168.1.21, I believe. We'll double check on that. We've got our backtrack machine right here. And the default gateway is at .1 on the same 192.168.1 network. So what we're going to do is we're going to ARP poison .1 and .21, not for everything, but just for each other, so that we're going to put our MAC address in each of their tables. So layer 2, we're going to be effectively implementing the man-in-the-middle attack. Next, once we have that going, we'll launch Explico, we'll capture that data, and look at it from the beautiful perspective that Explico can give us on that data. So let's get our devices lined up. This is the victim right here, the potential victim, I should say. And let's just go open a browser, just make sure he has functional connectivity to the internet. That's a good start. And let's also just find out what his IP address is to confirm. I believe it's going to be .21, and it is. All right, so that's the IP address. And while we're here, let's go ahead and do an ARP-A to show the ARP cache. And it knows about its default gateway's layer 2 address. That's great. We needed that when we went up to the web. So if he didn't have it, he would have ARPed and learned it. So that currently is the accurate, real MAC address of his default gateway. So let's go ahead and put this guy to the side for a moment. Now, this backtrack system, what I did was between now and the previous nugget, I rebuilt my backtrack. I had been doing so many various things, so I did a complete fresh reinstall from the CD. I just told it not to use a static address, go ahead and use DHCP, which it does by default. It has an IP address, and I'm ready to go. So no additional tweaks or anything else we've added above and beyond the defaults from the previous nuggets are here in this backtrack. It's just the way it came pretty much from the initial installation. I did, however, do the apt-get update and the apt-get upgrade just to make sure I have the current flavors of all the software. So let's launch Ettercap. So I'm going to just do it from a command prompt. I'm going to type in Ettercap -G for the graphical version, and poof, there it is. Now it just sits there waiting for us to do something. So let's go ahead and tell it we want to go ahead and sniff, and we're going to use unified sniffing. We're then going to specify that we want to sniff on the Ethernet 0 interface. Next, under hosts, we're going to say, you know what? We need to find all the hosts on this network, so we're going to say scan for hosts. That takes very short period of time. And then we're going to go back to this host menu and say, please give us a list of the hosts you just discovered. And that'll give us a list of all the devices on that network. Now, we're really concerned about two primarily. One is going to be 1.1, which is our default gateway. So we're going to highlight him. That's our default gateway, and click Add to Target 1 right here. And then we're going to select our victim, which is at .21, and we're going to say add him as target 2. So what's going to happen is it's going to go ahead and it's going to ARP spoof, poison the ARP cache of both those devices. The ARP poisoning that's going to be done is going to train .1 and .21 that the MAC address of the other one is really the MAC address of the backtrack system. We've got a layer 2 man in the middle once we turn this attack on. To turn the attack on, we're going to go to man in the middle. And we're simply going to say, I want to do ARP poisoning. It knows who the victims are, and we're going to click OK, and we are off to the races. Now, just to verify that that is working, let's go back to our client, and let's just do the ARP A again and see if that changed. And sure enough, it's changed. If we take a look at the 192.168.1.1, it used to be this MAC address. Now he believes it is B9. And we've also spoofed the router. So effectively right now, we are a man in the middle. Now, what I'd really like to do is just make sure that we can still get to the internet. Now, that's an old browser that was open. Let's go ahead and open a new one and just verify that we can still get out, for example, the same website, google.com, and that is not working. Okay, so it's not working or it's taking a really long time. Okay, so here's probably what we need to do. We probably need to enable IP forwarding on the Backtrack system. We've done that in a previous nugget, but this is a fresh machine. So let's go ahead and go back to Backtrack. We'll open up another console, and let's use this command. We're going to echo the value of 1, and we're going to redirect that with the greater than symbol to this file. And the file is called IP_forward, and it's in the folder under proc_sys_net IPv4. So the only thing that's in that file is a value. 0, no, I'm not doing routing, or 1, yes, I will do forwarding for other devices. That definitely needs to be in place. So we'll go ahead and turn that feature on. Let's go back to our client and see whether or not that's going to make a difference. So we'll open up another browser. We'll go to the internet again, and we'll try Google one more time. Okay. And now it's working. So the ARP cache is poisoned, and also very important, we are willing to forward packets, or frames in this case, that come to us towards their final destinations. So effectively, we're doing a man in the middle and not just a denial of service attack. All right, so we're going to dismiss him just for a moment now that we're capturing all that data. Now, we could use a lot of different tools to analyze this traffic. We could just turn on Wireshark and collect it, which is not a bad idea. Another option, however, I want to share with you is Explico. To launch this, one way of getting there is to go to Backtrack and then go down to Forensics, and under Network Forensics, here we have the option of Explico Web GUI, and we're going to select this one right here. I'll leave that up just for a second. That's the path if you want to launch it. And what it's going to do is going to launch effectively a web server. Now, if Apache's not already running, it'll start it for you. If it's already running, it'll just use that server function. And now it's telling us, okay, now to use Explico, the graphical user interface, just open up a browser right here. Now, here's the trick. Localhost is just referring to this Backtrack system's own IP address. If you know what the IP address of this device is with an ifconfig, you could, from a second machine, open up a web browser to this URL, so http:// IP address of the Backtrack system, :9876, and that is where Explico is waiting for you to log in. So we can go ahead and start capturing the data if we want to. So because it is a local machine, there's a couple options here. Number one, we can just right-click on that and say Open Link, and it's going to go ahead and use the default browser. I have discovered something interesting about the default browser, and that is the menu systems don't all work, at least in this distribution of Backtrack. So I'm not just going to open the link. I am going to copy this link, though. Right-click and copy, and let's open up Firefox. So we'll go under Internet, we'll go down to Firefox, and open up Firefox. We'll just put in that URL. So up here, I'm just going to right-click, paste and go, and that's localhost 9876. So right here, what I'm going to do is we're going to go ahead, and if you haven't logged on, in fact, I've logged on previously. Let me log out and show you how to log in because that's important. The username is XPLICO, and the password is the same, XPLICO. So go ahead and log in. And it's saying, do you want to remember my password? I'm going to say, no, thanks, but I appreciate you asking. So I'm logged in as Explico. Now, how do we capture the data that's currently being seen on Ethernet 0? What we're going to do is we're going to create a new case. So I click on new case, and I'll say, I want to do a live acquisition. Also, which is really interesting, let's say you have a capture file from Wireshark, and you want to analyze it. You can just say, I want to upload a PCAP file, and then analyze the existing file instead of looking at it live. So either way works great. So we're going to say live acquisition. We'll call this CBT Nuggets, and I'll go ahead and click on Create. So now I've got this new case. I'm going to click on the case, and from that case, I'm going to say I want a new session within that case. So we'll call this Session 1. Now, if you're doing a whole bunch of these, you could organize these by what you're looking at that day or that hour or that minute. The actual name isn't going to make a whole bunch of difference with a single capture. So we'll click on Create. So now we have this new session set up. What do we do with it? And we're going to click on it. So we have a case, we have a session, we've clicked on that session, and over here on the right, we're going to specify the interface that we want to listen on, which is our Ethernet 0 in the case of this backtrack system, and we'll click on Start. Now it's capturing all that data that it sees. So let's go back to our victim machine here for a moment. Let's just verify that we haven't gotten worse off. I want to make sure we still have internet access. A lot of stuff can go. Okay, so life's good. And everything that's currently happening is being captured over by Explico. So let's go ahead and let's go to images and let's search for something safe. What is safe? How about sand? There we go. Sand's pretty safe. So all the images and so forth right here are basically being captured. We'll go ahead and we go to the next page. Yeah, sand is really safe. That's a safe image. And what else could we look for? We could look for example, dogs. That might not be cool. Oh, look at them. Aren't they cute? Okay, so there's dogs, or a dog. And it looks like I'm trapped in some website's clutches. In any event, we got enough, I think. So over here on the left, you see the numbers are increasing. And if I had different types of traffic, Explico is going to classify that and tell me all about it. I'm going to go ahead and say that's enough. I'm going to go ahead and minimize that. And let's go ahead and click on Stop. Now, what I've noticed is if I use the default browser with this, these options over here didn't work. I could hover over these, I could click on them, but it just wouldn't function. There was something limited in that browser that wouldn't let it happen. Also, I noticed that even with Firefox, there's this NoScript plugin, and the NoScript plugin won't let the scripts run either for these to come up. So if you want to use Firefox, which is great, go ahead and click on the NoScript option and tell it that you want to go ahead and allow all scripts, at least for the duration of your Explico session, if you want to use the menus on the left. So that was a couple of stumbling blocks that I want to help you avoid. Number one, the default browser, don't use it. Number two, if you use Firefox, go ahead and allow all scripts if you want to be able to navigate. So what happened there in the background while I was chatting with you is that it actually went through and decoded all of that content. So it's got all that content, decoded it, and now we can take a look at it. So for example, if we want to go to graphs, and we want to look at DNS. Let's take a look at DNS. These are all the DNS that went on just in that little demo, and there's 10 pages of it. Holy schnikers. That's a lot of DNS. Probably the number one application as far as hits go inside of a network if we looked at all the traffic, because DNS, you could have one page you go to, and you could have 5 or 10 DNS hits just on pulling down the different content. So this is all the DNS that it saw. Again, 1 page out of 10. If we look at ARP, here's all the ARP that it saw. That's cool. Now, there's also going to be a little extra ARP because we still have the attack running. we're still launching that attack, and we're periodically refreshing that information to attack the default gateway and our host at .21. So that's probably why we'll see a little bit more than normal of ARP traffic. So if we go down to web and open that up, we can take a look at all the sites that were visited. Here's all the URLs that went on. We have additional options here. If we want to take a look, for example, at, I don't think we went to any video, but if we had video that we capture as well, we could say click on go, and it would show us all the URLs that were based on video, which we didn't have at the moment. Here again is all. We can click on go. That'll show us everything. So you can whittle it down a little bit as far as what you want to actually see right here. If we go down to images, this is a lot of fun. So we have 16 pages of images. Now, these are really like borders and stuff. Let's go ahead and let's go down like to page 7. Because early on, I think we looked at sand. There we go. So there's some of our sand images. We'll go to 8. And if there's anything too risky, I'll edit it out. There's all the graphics that we pulled down as we did our searching. So there we go. So there was one of our initial image searches, and all these graphics are right here. So Explico gives us a really great way to kind of categorize what we're looking for and then display it for us. There's also some other options for mail, voice over IP, software that we could use to share files like HTTP, FTP, TFTP, and so forth. We have chat traffic that we could capture and identify, shell traffic like Telnet. Holy schnikers, if somebody is using Telnet on your network, and there's so many easy ways to catch it and so many easy ways to view it. You can see what their passwords are and everything else they're used in the Telnet session. And then everything that it couldn't quite classify is going to be right here. And it puts it right here. So if it wasn't quite exactly sure of what it was for or what purpose it was serving, we can go ahead and see it here and do deeper investigation if we need to. Another option, which is pretty darn cool, is to take a previously captured file, for example, a Wireshark file, and just bring it into this to help us analyze that traffic. So to do that, we can go ahead and go back to cases. and we'll say I want to create a new case. We're going to use the default of uploading PCAP capture file, and we'll call this static file. And we'll click on create. Now once in that case, we'll go ahead and double click on that and create a new session. And for that new session, we'll call this test. And then under test, we'll simply say I want to browse for a file. And let's go ahead and use this one right here. It's voipcall.pcap. So if there was a voice over IP telephone call from that user that we're doing eavesdropping on, we could go ahead and capture that and analyze it. So we'll simply select that file, click on open, and then we want to click on upload. Now it says upload. It's like, what do you mean we're uploading? We're uploading it from our file system through the web service that Explico has provided for us. So once it uploads it, it'll decode it, and then it'll have it available for us to go ahead and look at. Okay, and it's analyzed it. So in the output here, we have some HTTP, but we also have some audio calls that it's telling us about. If we wanted to drill down and get more information about those calls, we go down to voice over IP, go to SIP, and here it would show us the relevant details or information. So Explico is just yet another tool that we can put in our tool belt of analyzing and looking at data from a big picture perspective. So what we got to do, because we don't want to leave that attack running, let's go ahead and turn off the attack. To stop the attack with EtherCap, we simply go to man in the middle and say stop the man in the middle attack. That should repopulate the correct layer 3 to layer 2 mapping, no longer being a man in the middle. And to verify that's working correctly, let's go back to the client just to take a look at their ARP cache. So back at the client, we'll go ahead and close that. So the ARP cache, the incorrect ARP cache is B9 for the default gateway. We'll hit the up arrow key, and now it's back to 13. So originally this is correct, that is wrong, and hopefully we've restored it so that the client can continue to go out to the internet without us being a man-in-the-middle attack. It'd be important for the correct ARP entry to be on this PC and also on its default gateway for them to communicate with each other. One other thing I'd like to do while we're here, we're talking about man-in-the-middle attacks and collecting data. Let me show you a really cool feature that Wireshark has. So we'll launch Wireshark and bring it up. I'm going to tell Wireshark that I want to go ahead and file, and let's open, and let's go ahead and go down to that same voice over IP call. This is pretty cool. So let's say we collected the data, and we want to analyze the voice call in more detail. To do that, there's this really cool option up here called telephony. I'm going to maximize this. And from the telephony menu, we can select the voice over IP calls. Click that, and it'll show us all the voice-related conversations that it recorded inside the capture file we're looking at. So, for example, we have a call setup, we have a call ringing, fantastic, and we have a call. So if we wanted to see and hear what was going on in that voice conversation, we could highlight this. Down here near the bottom, we can click on player. It'll go ahead and open up the player. We'll simply say I want to go ahead and decode it. And there's a visual representation of their call. And if we want to play it, we can go ahead and click on play. You know, there's just not enough ways to do a man-in-the-middle attack. In this nugget, we did an ARP poisoning attack like previous, but this time we used EtherCap with this nice graphical user interface to pull it off for us, which was fantastic. And then we used Explico to go ahead and kind of get a bird's eye view of the traffic and what happened in that captured data. We also took a look at how we could look at data with Wireshark and how to analyze a voice call using the telephony menu inside of Wireshark. I've had a great time. I'm so glad you joined me for this nugget. I hope it's been informative for you, and I'd like to thank you for viewing. Domain name system spoofing. Every client, in fact, one of the most frequently used applications on the internet today is DNS. People asking, hey, what's the IP address for this site? And what's the IP address for that device? Well, if we, as an attacker using Backtrack, can spoof or lie to a client about the IP address they should be going to, they will willingly try to go to our Backtrack system that maybe has been set up using the social engineering toolkit and is just a bunch of exploits waiting to take advantage of the clients who connect. In this video, we're going to focus on how to implement DNS spoofing. Let's begin. I'd like you to think back with me to the nugget where we did the social engineering toolkit and we created a malicious website. Wasn't that fun? So anybody who hits our website on our Backtrack system, we basically are going to own that machine. Well, how in the world do we get people to come and visit our system? One way of doing that is by doing DNS spoofing. For example, here's our user. And let's take a website that a user would typically go to during the day. I'm thinking Google, Facebook, other popular social media websites, and so forth. And if we can spoof the DNS, for example, when the user goes to google.com, they make a DNS request that says, hey, I want to go to google.com. Please, Mr. DNS server out here on the internet or maybe locally, can you tell me what that IP address is? The response comes back. The response is always at 24.30.something.something. And then the client says, okay, and he forwards a packet in that direction to the Google or the Facebook server, wherever he was going. Well, if we can intercept that DNS request and we can reply back. So when he says, I want to go to google.com, if we say, oh, it's at 192.168.1.15 or whatever the IP address is of our backtrack system, the user will cause himself through his DNS request to go ahead and visit our site. And once he's there, we now own that system. So using EtherCap, we can very easily do DNS spoofing between just two devices. For example, this specific user and his default gateway like we did before, and then add the DNS poisoning, or we can simply launch an ARP spoofing attack against the entire network. So everybody is forwarding traffic through the backtrack system. I would caution you on either one of these. You definitely do not want to practice with this on a production network, because it's possible to be a man-in-the-middle attack for everybody on that network. That means all traffic in and out is going through you, Mr. Backtrack. So that could be very devastating to a production network, and that could also be very devastating to a backtrack system that is not prepared to handle that quantity of frames and packets being forwarded through it. So let's have some fun with this. I'm going to show you two different ways of doing this. We can use the graphical user interface, or we can use just the command line with EtherCap. Either way works great. A couple of basics that we want to make sure we have set up. On the backtrack system, we want to make sure that that file called IP_forward, it has a 1 set in it, because if it doesn't, it won't do the actual routing of other people's packets. So if we're a man-in-the-middle attack, we want to make sure that's set. So every time you boot up or every time you're going to launch an attack like this, of course, in a practice network, you just want to verify that your IP forwarding is set to a 1. We'll do that again here as we set up. So we'll make sure that that is set to a 1 in our file on the backtrack. We're also going to edit a file called ether.dns. And that ether.dns is going to have information on how to spoof. For example, let's say, and I don't want to go to a production website here. Let's go use hurry.ws. That's a website that I use for a lot of tests and stuff. So let's say we have customers that are going to go out to hurry.ws. And in this ether.dns file, we would simply add an entry, an A record, for IP version 4, specifying what that IP address is. So if this backtrack machine is 192.168.1.15, which it is, by the way, on this network, and the customer is maybe at .23, which he is, I would edit my ether.dns file and say, okay, anything *.hurry.ws is 192.168.1.15. After we launch the man-in-the-middle attack, when this guy goes out, every time he makes a DNS request, if it matches anything hurry.ws, we'll intercept that and we'll send back the response 192.168.1.15, which at that moment his browser will try to connect to that, and poof, we own it. So the man-in-the-middle and the DNS can be done against the entire network, or if we want to be very singular and isolated like we did in a previous nugget, we can just choose, for example, this guy and its default gateway, just do ARP poisoning between just those two, and then either way, whether we're doing the entire network or just two devices, we can implement the add-on of the DNS spoofing. So let's begin by making sure that IP_forward file has a 1 in it. I'm going to take a look at it just by doing a more proxysnet IPv4/IP_forward, and currently it's set to a 0. So we want to fix that first thing. So to fix that, we'll simply echo the number 1 and redirect it into that file. And then, what we might want to do is just verify that it actually took. With a couple up arrow keys, the more command can just verify that we really are in the attitude of doing IP forwarding for other devices. And that's really important if we're going to be a man in the middle. Now we're going to modify a file called ether.dns, and to edit a file we need to know where it is. And a quick way of finding a file in the file system is using the command locate and then the file you're looking for, and we've got two of them. We've got one in an EtherCap folder and one in a VideoJack folder. We're going to edit the one that's in the EtherCap folder. Now to edit that file, you can use VI or you can use Nano or whatever your favorite editor is. I've already edited mine. Let me just go ahead and show you the contents. And I'm going to use the enter key just to go down just a little bit. Here's all I added to this file. I added one line. I said asterisk.hurry.ws. I added an A record. If anybody is looking for anything at hurry.ws, please feedback 192.168.1.15, which is the IP address of this backtrack system. And we can verify that real quick with an ifconfig. And sure enough, there's our IP address of 192.168.1.15. So anybody asking about anything at the domain hurry.ws, they're going to be fed back to 1.15 once this attack is in play. Now to test this, let me bring in a Windows 8 machine real quick. And let's do an IP config right here. So this guy's on the same network. This is our potential victim right here. He's at 192.168.1.23. And if we did a quick ping, for example, of hurry.ws, www.hurry.ws, it's going to feed back based on its DNS resolution, the IP address right here of 6470.1938. Fantastic. So it did DNS resolution to a globally routable address. And if we opened up a browser to that same website, we would have similar success as well. And there it is. Okay, so it works. DNS works. The website works. Everything's good. Let's go ahead and put him on the sideline just for a moment. And let's go ahead and launch our attack. Now, the graphical user interface is pretty handy and pretty easy. But very often, the command line interface, if we know the commands we want to issue, without ever having to go to the graphical user interface. So if we need syntax help for ettercap, do you remember how to get that? Ettercap space -H will give us all the help. So if we scroll up just a little bit here, so we have the -T option. That's for text mode for ettercap, as opposed to -G, which is for the graphical user interface. And if we scroll a little bit down here we've got a -P, which says we want to use a plugin. And the plugin we're going to use is the DNS spoofing plugin. And that DNS spoofing plugin is going to take advantage of that eder.dns file that we just had. So any DNS requests that come in, if they match any of our entries, those responses will go back to the client. So here's the attack we're going to launch from the command line. It's pretty powerful, and again, really big caution here. Don't just try this out, especially if you're on a production network, because you're going to do a lot of damage. Ettercap -T-Q-M ARP:*remote. Effectively, we're going to do ARP poisoning across the entire network that we're connected to. And we're going to use the plugin of DNS_spoof. We'll press enter, and it's off to the races. And you can get help by just typing in H, and that'll give you context-sensitive help right here. So if we type in H, there's our help. So let's bring back our victim machine, and I'm going to go ahead and give this guy a fair shake. I'm going to close that browser. I'm also going to do an ipconfig/renew just to release and get back an IP address. So ettercap saw the DHCP transaction. It saw my renew and the acknowledgement that came back. Let's go ahead and actually verify the DNS here. Let's do an up arrow key with a ping www.hurry.ws. Previously, when we did that ping, we got back the address right here of the one ending in 38. So 1938 with the last two octets. Let's go ahead and do that same ping again. And hopefully, if our attack is successful, we're going to get back the response of .15. And sure enough, there's the response we're getting back. It's .15. And if we opened up this website right now, it would take us to .15. So what's waiting for us at .15? Well, at the moment, I rebooted this backtrack before I started this nugget. But if we launched the social engineering toolkit and created a malicious website, what would be waiting for that client is a whole bunch of hurt and pain. Because when they connect to us, we would then own them. We could open up a Meterpreter shell and then use all those really cool techniques and features that Meterpreter, based on that exploit, is going to give us. Now, what we ought to do also is stop this attack. So to stop the attack, in fact, there's our little message. It's fantastic. So that's just another confirmation that the actual spoofing is happening. And to stop this attack, we're going to go ahead and hit Q for quit. And that's going to stop the ARP spoofing. It's also going to repopulate the accurate MAC addresses for the clients. So if we go back to our client and we do an ipconfig renew once again, just to kind of give them a fresh start at it. And when we do our ping again, it should come back with a valid IP address of www.hurry.ws. Let's verify that real quick. And sure enough, it's back to a 6470.1938 as opposed to the RFC 1918.192.168 address space of our backtrack system. So our network is now back to normal. So if we want to do the same type of attack from the graphical user interface, we could do so as well. Look, it's even giving us a mention that, oh, we disabled the IP forwarding. You might want to re-enable that. So if we are using the graphical user interface, you'd want to do this command first to make sure that IP forwarding is enabled, and then edit the eder.dns file like we did a few moments ago to make sure you're going to put in your spoofed information, and then you can go right to the graphical user interface. So here at the graphical user interface, if we wanted to edit that eder.dns file from a graphical editor, that would be perfectly fine as well. But from here, we'll simply launch EtherCap, and to do that, we'll do EtherCap-G for the graphical user interface. And under sniff, just as we did before, we'll do unified sniffing, and then specify the interface, which is Ethernet 0 on my system, so we'll use that. And then we'll go ahead and say, okay, I need a list of the hosts. So you scan for hosts. That takes like a few seconds, and then you say, I want to view the hosts. And these are steps we've covered previously in the man-in-the-middle attack. So these are all of our hosts. So if we want to spoof the entire network, we could, or if we wanted to spoof just, for example, the default gateway, add him to target 1, and our victim at .23, add him as target 2, we could do that as well, and then just go to man-in-the-middle and say, I want to go ahead and start the ARP poisoning, and away it goes. So now we're spoofing those two. That's the man-in-the-middle attack like we had previously. Now, to add the plugin for the DNS spoofing, we're simply going to go up here to plugins, say manage the plugins, and I want to go down to DNS spoofing, double click on it, and ta-da, it's now done. And that should give us the same effect, except this time it's only going to affect the client at .23. As it makes the DNS request, it won't affect the entire network. In this nugget, we've taken a look at using DNS spoofing, and the command line option with this was spoofing the entire network is a really quick way to get a lot of devices redirected to the backtrack system. As always, we would never do any of this on a network unless we had explicit authorization to go ahead and do so, because it can cause a lot of grief for a lot of people in a hurry. I hope this has been informative for you, and I'd like to thank you for viewing. Dictionary attacks using Hydra and SSH. It's very common for administrators, if they want to remotely manage their devices, to go ahead and use secure protocols like SSH and SSL. However, if those ports are open and those services are running, it also opens the door to some type of a dictionary or brute force attack. In this video, we're going to walk through specifically how we can use the tool called Hydra to implement an attack using a dictionary list that's over 14 million different possible combinations. Let's begin. I'd like you to imagine that you and I have been challenged in an authorized way to compromise a router. And that router could be a Cisco router, Hewlett-Packard, Palo Alto, Juniper, it doesn't really matter. We've been asked to compromise the router. Well, how could we do that? Well, number one, if we have physical access to it, we could power that puppy off and then do a powered up, break the boot sequence, and do the password recovery based on that vendor's method for password recovery. However, let's say it's on the third floor of a building. So there's floor 1, 2, and 3, and we don't have physical access to it. We can't power it off. How can we compromise it then? Well, one idea would be we can eavesdrop. We find out who the administrator is. Let's say it's Bob. And the next time he opens up a remote management session, we can eavesdrop. Now, if he's using Telnet, we could do a man-in-the-middle attack. Pretty easy to get the Telnet information because it's all plain text. However, today, most administrators are not going to be using plain text protocols like HTTP or Telnet to manage their devices. Why? Because they are plain text. So let's say he's using SSH. Now what can we do? Well, if Bob's using SSH to manage it, he has this encrypted session between him and the actual router itself. It's not going to help us too much to eavesdrop on the encrypted data. But what we might do is we might go ahead and do a dictionary attack against router 3. A dictionary attack is when we simply try to log in over and over and over and over again using all the words in a dictionary list to go ahead and try to log in. Now, it just so happens that Backtrack ships with a couple of password lists or dictionary lists, and one of them is like 14 million long. So if we try over and over, it might take a while. But if they haven't put precautions on R3 that stops after so many failed login attempts and locks out the account for a period of time, we could certainly do that. And depending on how many VTY sessions they'll allow at a single time on this device, our process might be slower or faster based on the actual amount of VTY lines they allow. By default, most Cisco routers allow a total of 5 simultaneous sessions, 5 VTY lines that are open. Other routers may have more, and that would give us more opportunity, a bigger attack vector to go ahead and try again and again and again. So here's what we're going to do. We're going to use a tool called Hydra. We're going to tell who our victim is that has port 22 open for TCP, which is what's used by SSH, and we're simply going to fire off. Log in as admin. Try this password. Log in as admin. Try that password. Now, if we aren't sure what the actual user account is, we can also have a user list. So we can say try logging in as admin, try administrator, try logging in as root, and then go ahead and try all these passwords with each of those user accounts. And that is effectively a dictionary attack. And if their password is one of the 14 million we have in our list, we will, in time, go ahead and crack that password. And once we have that password and the user account, we can log into that device and own it. And the cool thing is this. If we don't want to use SSH to try to find out what the username password combination is, we can try other protocols. For example, if they have SSL running or HTTP running or FTP, we could try on those protocols and those ports to try to log in. It's very likely that if we succeed at discovering a password for FTP as an example, we can then use that account or potentially use that account to log in through another mechanism like SSH. So let me introduce you to our players. First, let's take a look at Mr. R3. So on R3, if we had this access, by the way, you and I, we wouldn't need to compromise it because we're already logged in. I just want to show you some of the details on this device before we start the compromise. We'll do a show run with the pipe. I just want to include any lines in this running config that include the word username. And we have a couple of volunteers here. We've got a user called admin and a user called Keith. And both the passwords are not visibly obvious, at least at this point, what they are. Now this indicates that they use the old enable password command, which is really old and weak, and the 5 represents that you actually use the enable secret command for that one. In any case, as an attacker, we wouldn't know what the actual passwords would be for any accounts on the system. Next, let's you and I ask this router what ports it's currently listening on. And the show control plane host space open ports command on a Cisco iOS router is one way of revealing that information. And here's what it says. It says, well, guys, I happen to be listening on port 22. I'm listening on port 23 for Telnet, which is a bad idea always. And then I'm also listening on port 80, which is also a bad idea for management because that's plain text as well. And he's also a DHCP server on port 67 for UDP. That's great. So we know they have SSH and Telnet that are possibilities. Let's go ahead and focus in our attack on 22, port 22, which is SSH. On this backtrack system, we should be in that same layer 2 VLAN as R3. Let's go ahead and informative for you, and I'd like to thank you for viewing. Data collection with Maltego. This is absolutely amazing. See, the challenge is we may have to go out and gather a whole bunch of details regarding a certain organization. What web servers, what top-level domains, what mail servers they have, what MX records are out there for them, what the IP addresses are, etc., etc., etc. Gathering all that can be very tedious. Maltego is a graphical user interface. Oh my goodness, that makes this so simple. With just a few simple clicks, it can deliver tons of that very important data in a nice graphical user interface that makes it very easy to sort through. Let's begin. It is absolutely amazing, the sheer amount of raw data that is available to virtually anyone on the internet today. I'd like you to imagine that you and I have been hired by a company that wants us to go ahead and do a penetration test against their enterprise. Now, part of the work that we're going to do is gathering data. We're going to do some reconnaissance, find out what the servers are, what the IP addresses are, what domains are in, and so forth. And one really amazing tool that can assist us in gathering that data is a tool that's included in both Backtrack and Kali Linux called Maltego. Maltego is fantastic in that we can ask it questions about, for example, let's say we have a domain called cbtnuggets.com. And we could ask things like, okay, are there any other top-level domains that start with CBT Nuggets? And it could go out and search, and maybe it finds, 4 or 5 others. 1, 2, 3, let's say 4 in this example because I drew 4. And then we could say, great, now we have all these top-level domains. Show me all the mail servers, or show me all the web servers associated. Again, all based on DNS information with those record types. And they could show us the web servers or mail servers associated with those. And then we could drill down further and say, please show me the IP addresses associated with each of those devices. So it's a fantastic way to do a bunch of reconnaissance to find out more and more detail. And again, it's all based on the publicly available information. Now, the method that Maltego uses is something called transforms. And these transforms are already built into the product. So, for example, if we had a domain, cbtnuggets.com, and we have a web server, we could say, I want to run a transform that's going to go ahead and derive what is the IP address for that name. Now, how is that done? That's just done with a simple DNS lookup. That's not magic or anything else. But the cool thing is that the transforms, and there's hundreds of them that are written, are going to automate that process for us, do the request in the background, and provide the output in a beautiful graphical user interface that's very easy to interpret and go through lots of data in a very quick period of time. In our example, we'll go ahead and gather some additional information regarding a domain. We'll dig down. We'll use the transforms to get additional information. I'd like to point out something very important, is that this tool is just gathering information that's already publicly available. However, if a person starts gathering information against a specific target, a specific company, that could be considered by that entity to be malicious. So even though we're not implementing any type of an access attack, we are definitely doing reconnaissance using publicly available information. So I just want to give you a word of caution that you shouldn't just use this tool indiscriminately against any website you want to, because some environments may consider it as being hostile. So to launch this, we could use the menu system here and find it under Backtrack, Information Gathering, Network Analysis. I think it's going to be in several places, including SMTP analysis. There's Maltego there. It's actually in other places as well. And on Kali Linux, it's in a slightly different location. The fastest way probably to launch Maltego is simply to bring up a command line and say Maltego, just like that. That will launch it for us. Now, once it's launched, it's giving us a quick start menu here. I'm going to go ahead and click on cancel. I'm going to walk you through it manually. Also, the first time you use this, it's going to want a user ID for you. It's free to create. You need to create one online, verify it through an email message that comes back to you. And once you have that login, you can go ahead and log in as that user and start using this tool. They also sell this product. I'm not sure if you can pick this up. That says 12, that says 50, that says 255, and that says 10K. So with the free edition, they're simply limiting you to how much results you can get back in through your actual queries. So for individuals who license it, the actual number of results can be set higher based on their license. Let me go ahead and move this around. I'm going to maximize it a little bit. So the first question is, how exactly do we get this process started? Now, we could use the quick start menu that came up. However, we also have this option right here. If we click on that little plus symbol next to the graph paper, it's going to open up a new graph for us. So that's the quickest way to go ahead and start using it. So I'm going to go right here, click on that. It gives us this brand new graph right here. So this is the start page where we began. And once we're on a new graph, we then have this new set of tools over here on the left-hand side. So let's begin. So what I want to do is, as an example, take a look over here on the left. We have tons of options. Autonomous system numbers, DNS names, domains, IPv4, MX records, NS records, NetBlocks, URLs, websites, etc. If we scroll down, check this out. We also have personal information, aliases, documents, email addresses, social networking, Twitter, Facebook, etc. So we have a whole boatload of options available to us. I'd like to go ahead and do an example with a domain. Now, how do we start doing research on a domain? The answer is you click on domain and you drag and drop it over here to the graph. And by default, this domain is the company that makes this product called Maltego. So if you want to change that, for example, we can just double click on it and then type in a new name like cbtnuggets.com. Again, this is not an access attack or anything else. We're just going to gather information that's publicly available about this domain. So once we've changed the name, now you think, well, Keith, we're looking at cbtnuggets.com. How do I actually get more details about that? And this is where the transforms come into play. What we could do is we could right-click on this object, say Run Transform. Now, here's the temptation, which is not a good idea. The temptation is to say, all transforms. It's just going to dump a boatload of information on your screen, and it's going to be hard to wade through all the details. So let's do a little more specific examples. Let's say that we want to take a look from all transforms, and we want to get more information. The little eye indicator here, if we click on that, it'll open up a web page with more detailed help on exactly that transform. For now, let's do this. Let's go ahead and see if there's other top-level domains regarding CBT nuggets. So that's the transform I want to go ahead and run. So I'm going to click on that, and now it's running. So in the background, this transform is now running for us. And here we have the results, which means there's other top-level domains that are CBT nuggets. So over here, check this out. This little box, we can drag that around. That'll help us navigate if we have hundreds of thousands of objects that are showing up on our graph. And we can also resize it. So up here we have some resize tools. If I want to make it bigger or smaller, I can use these tools there as well. And there's different ways of viewing this as well. Besides having this view, which is the main view, we can go to bubble view, and we can resize that as well. And once you resize to a certain level, just get the icon like the overview up here. And this little color-coded legend is going to tell you what you're looking at. We're looking at domains. So I've got 7 domains that are all cbtnuggets.something. If we want to go to an entity list, it gives us a nice little list that we can resize those columns. It'll tell us exactly what those entities are, what those domains are. So let's go back to the main view. And let's say we want to get more information on these devices. Because they're all domains, how do we select them all? We just highlight all of them. So I missed that top one, so I will go ahead and hold down my Shift key and include that as well. And now let's run a transform against all these. Let's ask it politely, hey, can you tell us, Mr. Maltego, can you tell us what websites are associated with any of these domains, ones that are highlighted? And to run that transform with them all highlighted, we simply right-click, say Run Transform, and from the All Transforms list, we'll simply go to, wow, there's several options. We have a website DNS to website quick lookup using search engine. So probably any one of these would work for us. I'm going to use the, let's find out what website's using a quick lookup. And that's just looking into DNS, looking for a www record. And there's the results of this. So we can navigate using this up here. So cbtnuggets.com, we've got a website there. And you notice all the websites are in green. So if we shrink this down a little bit, so the domains are right here in this color, and the actual websites are the green ones right there. So if we want to drill down even further, let me go ahead and make this a little bigger. And let's say, for example, we want to go ahead and find out what is the IP address. Now, we could do it to all of these devices or just one. It doesn't matter. So let's take cbtnuggets.com. And we'll right-click. And now, from the command line, could we do this? Yes. You could use NSLOOKUP. You could do a ping of that, see what comes back. So to ask it, we can say run transform, and then from the all transforms option, look, we have now a smaller list. Oh, I said replace with thumbnail. Okay. So the transform was to replace with thumbnail. So instead of getting the web server, I get a little icon for the actual site. Funny. So let's go back to this now. I'm going to go run transform. And let's say I want to find out what the actual IP address is for that website. I can simply launch this transform and saying I want to resolve it to an IP address based on DNS. And what it will do, it'll go ahead and resolve that for me. So if we go find that information, here we go. So it moved it over to the right, and you'll notice these blue icons now represent the actual IP addresses associated with www.cbtnuggets.com. And if we shrunk it down a little bit, it would show us the color-coded information right here. So the blue represents IP addresses, the orange represents domains, and the actual green represents website. So I think you get an idea of how powerful this could be to very quickly sort out a lot of details, again, based on publicly available information regarding the stuff that's out there on the internet. So it's really easy with just a few mouse clicks to go ahead and gather boatloads of information and sort through that information. So if we wanted more details, for example, on any one of these entities, whether it's a domain, a web server, or an IP address, we simply right-click on that, say Run Transform, select the list of all the available transforms, and then pick the one that we want to go ahead and use. Now, one thing I noticed that was pretty shocking, I tried this on a couple other domains that I have control over, and I was absolutely shocked by the amount of information that it was able to reveal, including phone numbers and email addresses and so forth. So here's what I would have you do. If you're going to test this and practice with it, I would strongly encourage you to do it on a domain where you are authorized or you manage that domain to make sure you're not going to step on anybody's toes or make red flags go off as you make the queries. Now, some of these transforms, when they're run, it's going to ask you that you have to acknowledge that you're doing it. For example, I'm going to go ahead and say I want to run all transforms against this domain. It says, are you sure? It might take a long time. You might get a lot of data that you don't need. I'm going to say yes because I want to show you this screen right here. For specific transforms in the all set that we're going to run, you're going to have to acknowledge that, yes, I accept the disclaimer. So you'd want to read this. It's going to specify what's happening with it. You'll click on I accept, scroll down the list, accept all of them. If you want to remember that you accepted those, that's great. Or if you want to accept them every time. And then you can go ahead and launch that. So it's going to chunk through and it's going to run all those transforms to get that and get a whole bunch of additional data. Some of which that data won't be too useful for me, but I wanted to give you an example of the power and how quick this could gather all that information and put it right on our desktop. If we wanted to play with the views, there's different ways of doing that. We could use these options up here to sort it out in various different ways. We want to see it. And we can also use the bubble view, which again is just yet another way of viewing that data. And we can make it bigger or smaller just by using these tools right here for zooming in and zooming out. Once we get to a point where we can't see the details, it will give us the color code, the NS records, the domain, website, email addresses, DNS names, and so forth. And once we get big enough, it'll start showing us the details and the labels on those individual devices. And as we hover over any one of these entities, it's going to give us more detail right here regarding that object that we're currently hovering over. In this nugget, we've taken a look at this fantastic tool called Maltego, which allows us to go through the mountains of data, collect it, sort through it, and drill down to the information we want. Again, based on publicly available information that's currently sitting on the internet. Maltego is available in Backtrack and Kali distributions. It also happens to be available for other platforms as well. The transforms are there as a mechanism for us to gather specific information, again, that's sitting out there just waiting to be harvested or mined. And the example we used was gathering details about cbtnuggets.com. I would encourage you, if you're going to practice with this tool, again, practice with a domain that you're in charge of or affiliated with where you won't get in trouble for gathering that information based on your own domain. I have had a great time. I'm so glad you joined me. I hope this has been informative for you, and I'd like to thank you for viewing.